talk about some vocabulary here with hyperbolas. First of all, what do you think these are called? The vertex. Good. Or vertices. Let's actually make these red. Hey, maybe this means I'll actually get in the yearbook this year.
Oh,
it's not in me. It's not all about me. Okay. All right. So we have vertices. Okay, right here. Let's point at them. Don't want to do it that way. Okay, so what do you think I call these? The foci. Good. You know, some people do call them foci. You're not taking a picture of him on the phone, right? Oh, gotcha. Okay. Okay, so here's foci. Let's change it with a different color.
Wow, that's like a magic trick to make it look nice when it's right.
It is like a magic trick, huh?
I wish we could do that.
Okay. There's a couple other things that I want to talk about here. First of all, we call these guys branches. Okay? Now here, this is a branch and this is a branch. I don't think I really need to label that, though. And there's one other thing that I really want to concentrate on. Out of the book. No. Out of the book. Then put the chair out in the hall and go read the book. Thank you.
You don't like the book is smaller?
No. Okay, this is called the transverse axis. Can somebody tell me what the axis was called on the ellipse? Let's compare and contrast. So the transverse axis is actually called the what axis on the ellipse? The major axis. So we don't call it major and minor anymore. We call it transverse, and transverse means to go through. Okay? Kind of like if you forget which one's which, what's the transversal? What's a transversal? Remember what a transversal is? Really? Is it all geometry? We have a problem, but we have a really big problem when we have two lines and you have a transversal. Why do you think they call it a transversal? Because it goes through both lines. So, this is the, guys, you guys are being way too chatty. So this is called, oh wait. Do you see the look I'm giving you, Mom?
You just beat him at 2 tests and you lost it.
Transverse axis. Okay, we call the other axis, what do we want to make? Pink? This axis is called the conjugate axis. Why do you think, how could you remember that? Somebody who has, why was it, how could you remember the conjugate axis? Yes, Evan.
Transverse is on the edge,
but it won't always be on the edge. Transverse goes through, conjugate is the opposite of going through, right? Kind of like when you take the conjugate. how if you have 4 plus root 2, then you multiply it by 4 minus root 2, right? Multiply by the conjugate? Yes. Yes. It's the axis that goes right through the middle of the 2 branches that doesn't touch. Okay? All right. There's something else in here that's really cool. So check this out. Let me give myself a box here. Give it some color. Seriously, too chatty.
It's such a Tuesday.
I don't care. Okay, there's this box that's in between these branches. And look what happens. If I take, I don't want this line to be, let's do this. Make it all fancy. If I take and go from this corner to this corner of my box, and go all the way through, okay, my box is not big enough. You know how I know why? I'll tell you exactly why. You see what's happening? I grabbed the wrong thing. That's what I want. And then I'm going to flip it. Do you get it? Okay, you tell me. You tell me how I said my box wasn't positioned correctly. It would be at the corners. Okay, but how do I know it's off? What relationship's going on here?
I'll be honest, I don't remember showing. It's been a while.
I'm going to redraw my box. Okay. Do you see how these are asymptotes? Asymptotes means that the graph, what? Never touches them. Right? So these right here, these branches will go on right along that asymptote there. And there's a box that we can draw. We usually do it in the reverse. First we draw the box, then we draw the asymptote. How's that look? Horrible? I don't think it looks horrible. It doesn't look awesome, but it doesn't look horrible. What do you think now? Better? Okay, the reason that you don't have it as a solid box, it's going to be easier on your homework if you draw it as a solid box. You'll be able to see it better. But you don't want to draw it as a solid box because it isn't a box, right? It's like imaginary lines that kind of guiding these branches. Yes. No. You're going to use it to guide your graph. Okay? You're going to need to draw it. Okay. This all looks very foreign because it's all brand new. Okay? But, Mitchell, will you come up forward more? It bugs me that there's an empty seat in front of you when you're that far back. Awesome. Thank you. Even better yet, you can come over here if you want. You're good? Okay. It seems complicated because I'm throwing it all at you, but when we start doing these, it all kind of unfolds the way that all of these pieces of it relate. Okay? You guys ready? All right. You can write that down. How many of you would like to write it down? Or would you rather just print it out at home? Okay, moving on. Ooh, this was for me to be able to label. That's what's hard. Okay, let me see. Let me think for a second. Okay, so here is the equation of hyperbola. Let's talk. There's the equation of a hyperbola. How does it look familiar to you? It does look familiar to you. It looks like an ellipse, only, just like Mitchell said. What'd you say, Mitchell? It's got a subtraction sign instead of an addition sign, which is kind of cool because if you were to take these two branches and put them towards each other, what do you think they would do? Not a circle. It would look elliptical, right? Okay. So it looks just like an ellipse, only it has a subtraction sign. All right. I don't even think I want to do that. I think I just want to keep going. Okay, here's a different one. What's different about this one?
Oh, the A and B are...
I'm hearing some good vocabulary. The transverse axis is what? Vertical rather than being horizontal this time. Who thinks they could tell me what is the formula here? Mrs. Watkins, is the formula here? It is. Evan, thank you for raising your hand. You know what you want to say. Okay.
minus 8 squared over B squared minus Y minus K squared over A.
Okay. Was he right? Okay, let's talk about this for a second. I really want you guys to think. Let's grab the other one. Let's grab this one. And this one. And let's compare and contrast them for me. What switched? Okay. The X and the Y change. But what changes in the ellipse? The A and the B, right? Can anybody tell me why the A doesn't change? The A and the B don't change. Why does the X and the Y have to change? Because remember, what does the A and the B, what does that matter when it's an ellipse? Okay, I need somebody to raise their hand. Okay, Mo. Okay, these are always positive too. The A is going to be positive and the B is going to be positive, right? Okay, but you're answering my other question, right? Okay, let's go back to ellipses. What changes in an ellipse? The A and the B. Why do the A and the B change in an ellipse? Can somebody raise their hand and tell me why A and B interchange with ellipses? The size of what? Of the shape itself. Okay, so tell me more. Tell me more. You didn't want to say it out loud. Okay, Clara. Okay, it controls the height and the width of it, right? So what happens if, let's put an x squared and a plus sign and a y squared. What happens if A is over here? Mitchell? It's taller. And what happens if A is over here? It's wider. Okay? And if we really, really wanted to, guys, I need you to really, really pay attention, okay? If I really, really wanted to, and I wanted to keep A in the same spot, always, and change X and Y, couldn't I just write it like this? Couldn't I? Couldn't I always keep the A in front and just make the X or the Y change? Answer that question. No, don't you normally see with an eclipse, don't you always see the X first and then the Y? And the A's and the B's interchange? couldn't you keep the A here and always make your major axis here, but just change the X or the Y? Think about that for a second. With an ellipse. You can't? I'm going to do an example. Okay. I don't want to spend this much time on this, but I really, really think that this is important for you guys to get. The reason I can switch them is it doesn't matter, right? You could put one in front of the other, or, you know, it doesn't matter. So we always keep the X first and the Y second, and then we make the bigger one be A. Correct?
Yeah.
But when we do that today, we can't do that. Why? Because it's subtraction. Right? Okay. So the bigger one has to always come. Right? The bigger one always has to come first. Okay. I am confusing you. All right, let's just get into it. Okay, so that all of that being said, I gave you all of it. Let's see if it unfolds all of my talking now by looking at an actual equation of a hyperbola. Okay, so what can you tell me? What comes first? No. I'm sorry, let me reword my question. Okay. Which one comes first, the Y or the X? The Y. So where do you think the orientation is going to be? Okay. It's going to look like this. Okay? All right, so where is, oh, you guys need paper. That would help. Okay, give me a second. Can you imagine that there's something else that we haven't talked about yet that has to do with hyperbolas? Okay, let's just go. So where do you think I should start? Just like, well, no, before that. I heard it already. We want to start at the center. What is my center? Negative 2, 6. Why is it negative 2, 6 and not 6, negative 2? Yeah, because the Y is over here and the X is over here. So you just have to switch them. So negative 2, 1, 2, 3, 4, 5, 6. There is the center. And I'm going to have branches that are going to do something like this, right? Okay. So what other pieces of information can I get from this? A and B. Okay. You don't even, with hyperbolas, it's kind of cool because you don't really need to worry about A and B because 49 is going to be associated with what? 7 or Y. So I'm going to start at my center and I'm going to go out how many? 7, just like ellipses, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 off your graph. No big deal, right? Okay, where do you think I'm going to go on the X? I'm going to go 2. 1, 2. 1, 2. See how it's very similar? Check this out. There's your box. That's the box, right there. What goes through the box? What do we call the lines? Vocabulary, guys. Asymptotes. That directs our asymptotes. So here's my asymptotes right here. Pretty cool? Check out how you can find, okay. As soon as you guys are finished drawing, I want to stop for a second because we need to come up with the equation of our asymptotes. Okay, so I'm going to give you the equation of the asymptotes one time in its regular form, and then we're going to forget about it. Okay?
So I shouldn't write
Okay.
it down?
So I don't think you need to. We will with this, but I don't think you need to. It's y minus, what do you think? K equals plus or minus your slope, and I'm going to write slope like this,
Isn't it 12 times?
times, no, I'm just going to write it slope. Slope times what? X minus what? H. Okay, so let's write the equation of our asymptotes with this one. Okay, do I have a y value that I need to worry about? Yeah, it's right here. Isn't this part of this equation already given to you right here? Asymptotes are y minus 6 equals, let's count our slope. We've already counted our slope. Do you remember when we counted our slope? 1, 2, 3, 4, 5, 6, 7, 1, 2. Isn't that what we did when we were going up on our A and over on our B? We were finding our slope right there. The slope of that line is up 7 over 2. Or from here, it's up 7 over 2, right? Times, what would the x part of this equation be? It's right there for you already. X plus 2. Why do I have a plus or minus in front of this? Because I'm going down and up. This asymptote is going in the positive direction, and that asymptote is going in the negative direction. It looks super complicated, but is it really? You just take this piece, and that goes here, and you take this piece, and that goes here, and then these are, don't you have to go up 7 and over 2? Got it? See it? And those pieces are where this comes in, right here. It's my slope. All right, so one more thing I need to find before I draw. I could draw first, but there is one more thing I need to find. What do I need to find? The foci. So in order to find the foci, I need what? Okay, can anybody tell me? Okay, what's the one for ellipse? C squared equals? What do you think this one's going to be? It's going to be the inverse. See? See how that works? Ellipse was this, guys. Why did I erase all that? That wasn't very smart. This is ellipse, right? Isn't that how you found ellipse? So how do you find a hyperbola? Change the sign. What else changes the sign between an ellipse and a hyperbola? Right here, right? It's almost like opposite. So this is a ellipse. This is a, this works for an, and this works for a hyperbola. They're inverses. Okay, you guys ready? So if I want to find C, I would say C squared equals 49 plus 4, or C equals the square root of 53, plus or minus 53.
You the square root of all the results of the squares. Wish you could do that.
Yeah, wouldn't that be easier?
Square root of 7 plus square root of 4.
But it doesn't work. Okay, so what are the foci? Where would I plot them? The foci are going to be plotted what? On this axis or on this axis? Vertically or horizontally? Look at your picture. Where is my transverse axis, guys? What happened to it? My transverse, do I even need my conjugate axis on these?
No.
It is there though, right? Isn't it just right here? But on my transverse axis is where my foci are going to be, right? So they're going to be, let's see, I'm going to have to go, I have to move on my x-axis first, which is -2. Then where do I go? Up 7, and then what? Plus square root of 53, right? And the other one, I need to still go -2, only this time I go from 7 minus square root of 53. So that's somewhere like right here. I like to put a little line and an S and a little, you can't even see this one, it's up here. This is 7. So we have to go over 2, up 7, and then up root 53. What? Did I screw the whole thing up? Oh, 7. It should be 6. Sorry, I'm thinking 7 because 7's my rise. Mrs. Muller, mistake 1, right? Should tally them, right? Okay.
It's been a couple days.
Okay, do we understand, first of all, that C is how far we're going to go from the center up and down? Where's our center? -2. Now it's important, right? -2 what? 6 plus root 53 and 6 minus root 53. Makes sense now that I actually did it correctly? You can't, okay guys, this is a really good question. You can't put just plus or minus square root of 53 because what is the square root of plus or minus 53? Around. Or if it's between 7 and 8. So if I just said -2, 7, it would be here, and -2 minus 7 would be down here. So we have to go to the center and then add root 53 and subtract root 53. Let's do another one, okay? We haven't finished yet. Before I didn't want to go too much further into it. Okay, so I'm going to go up to the board and write it. I'm going to make it different. Any different color? Red? So it starts here. And add arrows. No, I'm recording, right? Okay. So it starts here and it goes. Isn't it pretty? Wait, is it supposed to be on the close side? No, it should be at the vertex. The close side is there, the vertex is there. No, you're having to get there. What's guiding you is your asymptote and your vertex. Kind of cool, huh? So to me, this is your hardest part here. Right? We'll do more. Okay? It takes practice. Because you're going, this is your center, right? Here and here, -2, 6, -2, 6. So the way to find your foci is to go to your center and then go up root 53 and down root 53. You're speaking, isn't that what you do? What is speaking? Is the distance from here to here. Remember the foci on an ellipse is on the inside? The foci are on the inside of the ellipse. Well, isn't that foci on the inside of that hyperbola, that branch? And this example kind of sucks because you can't see the other one. It's right there. Point of what? The foci? What do you think? What do you guys think? What's the point of the foci? It actually does something. If you've noticed, guys, if you've noticed with your ellipses, if your folks look at this, this hyperbola is pretty narrow, right? And the foci is being pulled towards the vertex, right? Well, what if the foci was down here more? What do you think the shape of this would be? Wider, right? just like on your parabolas. So focus on your parabolas. When it was wider, it would go away from the vertex, and then when it would get closer to the vertex, it would get thinner. It's doing the same thing. Behavior is the same. I hope I'm saying that correctly. Yes. It's the same as the ellipse foci. Exact same thing. How do you find the location of your foci on an ellipse? Start at your center and go positive and negative, right? It's the exact same thing. We need to practice more. Yes? Okay. Let's do more. Okay. You guys have it? All right. Let's do this one. What's different about this one? This one's number 3. The X is in front this time. What does that tell me? Ryan, I'm going to get irritated. That it's, okay, first of all, it says it's this way. That's way too fast. Okay. So, first of all, it tells me since the X is first, it looks like this. Okay, what else? It's not equal to 1, so we got to make it equal to 1, right? So don't we have to divide everybody by 2? So when I divide everybody by 2, I get x squared over 2 minus y squared over what? 1 equals 1. Where do I always begin? Center. What's the center of this? 0, 0. So let's start at our center. Okay, so my transverse axis is going to be what? Horizontal or vertical? Horizontal. Might as well get that guy in there. Okay. How far out am I going to be going? Not 2. This one's a little tricky. Rad 2. Exactly. Which is kind of funky, right? It's like what? Between what? It's between 1 and 2, right? So like here and here. What about my conjugate axis? Square root of 1 is what? 1. Some of this box is going to be small. Okay, got to draw my box. Okay, I hear questions. What are our questions so far? How did I do that? It's the same thing with our major and our minor axis, right? Only you're used to seeing numbers like this that are perfect squares. So you look at that and you tell me 7, right? How do you get 7? Square root. So how do you get this one? Square root. Okay, now what? Let's draw our asymptotes. Okay, there's our asymptotes. What's the equation of my asymptotes? I'm trying to make sure I'm not missing anything. Asymptotes. Remember, you've got the funky old y minus something over here. What is that going to be? What is it? What's my center? Y minus what? 0. Do I need to write y minus 0?
No, it's just y.
It's just y equals plus or minus
1.
what is my slope?
1.
Up 1 over?
1.
No.
It's not.
I went up 1 over what? Square root of 2. And I have x minus 0 or just x. We don't normally write this though. Why? Because you can have a radical in the bottom. So how would I change that? Multiply by radical 2 over radical 2. So what should I change my slope to be?
Two over radical 2 over 2.
Radical 2 over 2.
That's
Good.
tongue twister, Miss Waller.
That won't be on a test. Don't worry about that. Okay? For our purposes, it's the slope of this line. You already counted it, right? You went up and you went over. All right, so what do I need next? The foci. How do I find the foci? C squared equals A squared plus B squared. We already have A squared plus B squared. They're 2 and 1, right? So 2 plus 1, or C equals the square root of 3. That makes sense, right? Wouldn't it be on the other side? If this is square root 2, wouldn't square root 3 be a little bit more? Square root 3 is going to be like, I don't know, there. Make sense? Now, since this time we're starting from the center, I'm starting at, for our foci. So it would be before we start at whatever our center is, and then we go plus or minus however far the foci is, right? Now the center would be 0, 0, so this one's going to be really easy. So how far do I have to go away from the center to get to that foci? Square root 3, comma what? 0. And how do I go in this direction? Square root 3 in the negative direction. Negative square root 3, comma 0. I think it's easier if you see it here, like Mrs. Watkins does. But on your paper, it's hard to see on the actual graph. Negative square root 3, 0. So what's left? Let's graph it. I want arrows with it. And let's make it blue this time. But this will be more fun. So I'm going to start here, and I'm going to go all the way to my vertex. Isn't that pretty? Is it really that hard? It's tedious, I get it. Let's drag in. Again! What's wrong with me? Okay, not overthinking it this time. I kept forgetting that it has arrows on it.
Smaller, it's okay. You messed up. You all messed up.
Okay, so that technically brings me at, I had 1 and then I messed up 2 more times. 3 checks. I'm out. No. What? The asymptote on the last one. This one? So I drew my box, and they just go through. Oh, I gotcha. Okay, so I don't have a, yeah, it's 0, right? Do you want me to rewrite it? It would be like, there's nothing there, so there's nothing there. There's nothing there, so there's nothing there. Let's do another one.
But it's always going to be like Y.
Yep. Yep, it's always going to look like that.
Where do you have this little
This?
Yeah. What's the formula for that?
I am not going to give that to you. You guys have got so many forms. You guys have too many. There is no formula. It's the Y stuff goes on this side, the X stuff goes on this side, slope goes in front of it.
I have the formula.
I'm sorry, Y minus K equals plus
or minus slope.
Let's do another one. Come on, guys. I'm going to go all the way to the bell. You guys need help. Every one of you, unless you've got somebody waiting for you that you can't text, should be finishing this problem with me after school. Right? Right. Evan, do you want me to call home? You can't text him and say, give me 5 minutes? That's not a very good front. Okay. All right, so how do I need to change this? What's the first step I need to change? No. I don't want to see anybody packing up. No, I don't want to divide by 4. I got to move stuff. What do I want to move? The 25 needs to come over here. What will it become? Negative. Do we write a negative first? No, so which one's going to come first? 4y squared minus 25x squared equals 100. Now what would you do? Divide by 100. All right, so now I have y squared over what? 25 minus x squared over 4 equals 1. I think that on this problem, no, it's not. Gosh, I go so much slower than Mrs. Watkins does. Okay, so where's my center? 0, 0. Okay, how far up am I going to go on the y? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How far am I going to go over? 2. Hey, what's the asymptote? Y equals what? Plus or minus? How far did we go up? 5 over 2. Right? That's the slope. Let's draw them. Oh, we need a box first.
I'm terrible at that, and even with the word. I don't know if that's like a...
You're not terrible.
It just doesn't look good.
Okay, technically, couldn't I already draw in my... So I'll do that really quick. Is it vertical or horizontal? It's vertical, so it looks like this, right? Why do we know it's vertical? Because the y first, right? That's what we're orientation on. So it's vertical, so it looks like this. What else do I need? Foci. Okay, so c squared equals what? A squared plus b squared, which is what? 29, or, I should write that, 25 plus 4, or c equals the square root of 29. Okay, this is the hardest part, right? Where am I going to begin? From 0, right? And I'm going to go where? I'm going to go up. No. We're at 0. Up where? Up how much?
It's like in between 65, right?
Up root 29? Down root 29. What if I shifted this whole thing up 2? Then what would it be? 2 plus root 29 and 2 minus root 29. You see what I mean? You start from the center and you either go up and down or right and left. Good job, guys.